There is a debate among those who are closely following the transition to electric vehicles of whether or not Tesla has an advantage and if they will be able to keep this advantage. What's been said so often for the past several years is that the competition is coming. GM has 4 EVs on the market right now and recently reiterated its goal of selling 1 million EVs by 2025. That's what Tesla did last year and will double that this year. Ford currently makes 3 electric vehicles: the F-150 Lightning pickup, the E-Transit van, and the Mustang Mach-E. Toyota is falling behind quickly. Just last week, its CEO stepping down as they realize that they need a new plan. In China, there's BYD, NIO, XPeng, and others. Well, to help us truly understand how Tesla stacks up, we've got Cory Steuben joining us. He and I will review all of the different ways that Tesla has an advantage over their competitors, from the manufacturing, the factories, the business model, and the team. Cory is the president of Munro Associates. Well, thank you so much for joining me. Welcome, Cory.
Yeah, thank you for having me, Herbert. This is going to be exciting.
So between Cory, Sandy, and the other associates of Munro Associates, they are likely the best in the planet who knows the most about how different cars are made and about the auto industry and the competition in the auto industry. Munro Associates is the de facto leader in reverse engineering and teardown benchmarking. They tear down all sorts of cars, and they know every single part at every single price and the supply chain and what it takes to manufacture these parts. You can learn more by checking them out at MunroLive on YouTube, which was actually created by Cory, by the way, just a couple of years ago. And they've already grown to over 300,000 followers and over 41 million views, reaching the top 1% globally. So, Cory, can you help me and my audience get brighter about all the different ways that Tesla has an advantage?
I can do that. I can help you get brighter. Yeah. So,
Okay.
where do you want to start?
Let's get started with, well, what do you think? Yeah, let me ask you that. What do you think is the greatest advantage that Tesla has over competitors based on your experience, all the things you've taken down and learned about how they build cars, their factories, and others?
Their greatest advantage is how they integrate in their design of their vehicles. So, Munro Associates, our benchmarking capabilities spans back 35 years. And about 20 years ago, I did benchmarking studies for another OEM where we purchased every single Toyota, every one made on the globe. Imagine a warehouse filled with
Wow.
47 Toyotas, studying the minute differences between how wire harnesses were mounted to internal combustion engine vehicles, how the steering racks were scaled to large SUVs, medium-sized SUVs, and small cars. So we are trained at Munro Associates to look at how each OEM accomplishes functional objectives. And when I talk about functional objectives, is what do you want the car to do, and how can you design the car to do those functional objectives better? It may seem real theoretical, me just saying functional objectives, but if you think of the purpose of an EV, there are several factors that drive inefficiencies. So one is the weight, one is the rolling resistance, one is the resistance, their coefficient of drag. So Teslas are designed with those elements as the top core functional objectives. And then you have energy storage, the transfer of that energy, and then the efficiency of your powertrain. And when we first looked at Model S's and Model X's back in 2013 and 14, we really were not that impressed. They were an amalgamation of separate high voltage components, DC to DC converter, charge module, what you would see from a typical OEM, what we call a fragmented architecture. So fragmented meaning you had a box here, a box there, a pump here. What that does is it drives an inefficiency in the integration of those systems, because if you have separate components, you have to have separate lines, whether that's your low voltage communication, your high voltage lines, your thermal system. And then, so Teslas were okay in 2013, 14, 15, 16, the Model S and X. But when that Model 3 came out, it was not just one step change. It was like 3 step changes in thinking and how you design a vehicle, particularly in 2 areas, the thermal system and the high voltage architecture. The thermal system at that time had the super bottle, Now, the super bottle, if you remember, has now been replaced by the octo valve. These are
Octoval.
like, these are words that are synonymous with like great design. Well, the first people in the world to ever take a picture of the super bottle and get it out there in the world was me. I found it. I took a photo of it. I sent it to David Tracy at Jalopnik because we didn't have MunroLive, and he was the one who wrote that first article with the pencil drawn over the little super bottle man with a cape. So maybe you can find that B-roll for
Yes.
this. So Jalopnik
Well.
article. And the reason why the super bottle was so groundbreaking is because it took a system that was typically a dozen parts in different parts of the vehicle and combined them all together. So you had the two pumps, the bottle that housed the ethylene glycol, the valve, including all the ports for the valve, the sensor for the level, and the chiller, all mounted to one thing, emulating nature. It emulated what you would see in an animal for their heart. Imagine if your heart had the chambers that pump the blood and the valves and ports directing it through your body. Imagine if it was over here and over here and over there. The inefficiency of flowing the blood all over your body is just astounding. And that was just amazing. So first it was the thermal system. And then they also were using only nylon 12, so PA 12 lines for all the fluid, which are much lighter, slightly more expensive, but much less prone to leakage because they weren't using constant tension spring clamps. So I know I'm diving way down into the weeds right now. So now I'll go back to my other point. So high voltage architecture.
Can I ask you what you describe right now, those two innovations, they sound like innovations that any car might need, not necessarily an electric vehicle. Is that true, or am I overreading
So
to what you said?
the thermal system for the Model 3 is, it applies only to electric vehicles because if you think of the thermodynamics of an internal combustion engine vehicle, most of your energy is lost to heat and vibration. So a gallon of gasoline has north of 30 kilowatt hours of energy, which is a very small amount of volume and a lot of energy. But only a small fraction of that energy is translated into forward locomotion. Most of that is lost to heat in the actual combustion cycle. That heat is then rejected out the tailpipe and through waste heat in the exhaust system and catalytic converters, as well as waste heat in the radiator system. You know, think of a regular car. You have a radiator up front that's rejecting heat to keep the engine cool so that it doesn't overheat. That heat is an advantage for wintertime because you're actually capturing that heat and using it to heat the vehicle, which would otherwise be lost. Electric vehicles, it's completely backwards. The battery is really inefficient at storing energy relative to a gallon of gasoline. A very, very large battery that weighs 1,200 pounds or 1,000 pounds can store 75 to 100 kilowatt hours, which is the same as 3 gallons of gasoline. 3 gallons of gasoline weighs about 21 or 30 pounds. So, but the majority of that energy is translated into forward locomotion. And that's why when you need to heat the vehicle, now you're taking away a large amount of that energy that would otherwise be used for forward driving to heat the cabin through PTC heaters or heat pumps.
I see.
So the thermal systems that we were seeing that Tesla came out with does not apply at all to an internal combustion engine vehicle because how you're generating heat, how you're transferring it, the temperature ranges are all different. And that's kind of the point that I'm making, is that many of the traditional OEMs were still choosing EPDM lines, which can handle the higher temperatures generated by a gasoline or diesel engine, when that's actually not necessary for an EV because your temperature range is much more narrow because you're not dealing with the high temperatures of the combustion cycle. So there's hundreds of thousands or millions of decisions that are made when you're developing a vehicle. And at Munro, we have the luxury of being able to investigate and study these decisions decade upon decade with our team of 100 people. And it puts us at a unique advantage to provide a tremendous amount of context. So we can look at a thermal system and give the context as to why it's better and or why it's worse. And the second point I was making was the high voltage architecture. If you look at a Tesla battery and you take off the penthouse, so the battery has a small area that bumps up where you typically would have the fuel tank in an internal combustion engine vehicle. Well, under that penthouse, you have a module that holds the charge module and the DC to DC converter. They're all on the same board and they're all on a cooling plate. And that cooling plate has ethylene glycol from the thermal system pump into the battery and go on that cooling plate and out. But that's a separate loop from the cooling lines that run to cool the batteries themselves. So there's actually multiple paths for coolant flowing through the battery. And many people don't realize that. And the reason why it's an advantage is because those components, those high voltage components, are integrated under a cover in the battery, you don't have ultra expensive high voltage lines. So whenever you see another OEM and they open the hood or you see a design, like maybe an example of what it looks like, and you see orange lines running everywhere. And they almost show it like, oh, look at our EV, orange lines. If you see 1 inch of orange line, it highlights inefficiency. The best EVs should have as little amount of orange high voltage wire exposed. The more you have, the more inefficient your system. So a Tesla has orange line running from the charge port to the battery and from the battery to the rear motor. And if it has a front motor, from the battery to the front motor. And then it has a small line running to the high voltage AC compressor for the heat pump system. So it's a very small amount. Other EVs, yeah, go ahead.
No, I want that's a sentence I want to hear. Other EVs, but okay, two questions related. So first is, would you recommend to other OEMs, the ICE car OEMs, as they're trying to create an electric vehicle, that it's better for them to just innovate and start from scratch, or and then if you can expand on the number of components that you think that Tesla has an advantage. You've talked about the thermal, the voltage. What are the other things that Tesla has done that really gives them a good advantage for EVs? And then you said the other how the other EVs are being created at this point.
Yeah, and here's an advantage that many people may not think about: the badging on the outside of the car. So traditional OEMs will sell vehicles in 4 to 8 trim levels.
Right.
Think of Chevy, for example. You can buy a Chevy Tahoe LT. You can buy a Chevy Tahoe LTZ. You can buy a Chevy Tahoe High Country. You can buy a Chevy Tahoe RST. You can buy a Chevy whatever Texas Edition. Each one of these trim levels, they have small different variations in the exterior cladding, whether that's door sills, front fascia, wheel and tire package, mirror color versus mirror non-color. They vary the trim around the windows. Some are chrome, some are black, some are satin steel. You get different roof racks. The rear of the vehicle may have a different rear fascia. Some have quad tips for the exhaust. Others have a single. Now, it's painful for me to walk through all of those things. And I know this because I actually drive a GM SUV. And I have a Denali version, which is different than the non-Denali, which is different than the AT4. So me just walking through the different trims of an American SUV means that each one of those has a designer and a design and release engineer, which means instead of making 250,000 fascias for GM's large SUV, they're actually making 50, 30, or 40,000 of each. Because not only do you have the GMC model, you have the Escalade, and then you have the Chevy. So it's the same vehicle built in Texas, but you may actually have 15 or 17 different front fascias that will go on a large SUV rolling out of the Fort Worth factory. Think of that line side complexity. So when you have that person down there, I'm putting the trim on. What is this? Oh, it's an Escalade. It's got the Super Chrome. What is this? Oh, this is an LT Tahoe. The reason I'm bringing this up, describe how that conversation happens at Tesla. It doesn't happen. It's conversations that don't happen because there is only one Model 3 window trim color now. It's not chrome. They changed it in 2020. Do you remember the old ones were chrome and now they're
I did not get the chrome.
flat black?
Yeah.
And think of the badging on the car. They have a very Spartan amount of badging. The Tesla on the hood, I think the Tesla on the deck lid, and then you have, I think it says Model 3 or Model S on the rear. Very little on the side, no door cladding, no crazy plastic trims. It's a very, so Elon Musk was interviewed by Everyday Astronaut. Have you ever seen Everyday Astronaut?
Oh, yes. Mm-hmm.
And I'm going to paraphrase the quote. He essentially said, there's a lot of great engineers that waste a lot of time designing a part that should not exist.
Mm-hmm.
Now, some OEMs have built their business model off of offering a low trim level for 45 grand and the high trim for 90. But what they do is they build in an undue amount of complexity and cost to all of the manufacturing process, all of the supply chain process. And I'm picking on something that's very simple and easy to understand. And that is the exterior trim levels of the vehicles. And Tesla has proven that you can first, not change what the vehicle looks like for a long period of time. Now, that has been done by serious OEMs have kept the same style of a vehicle for 7 to 8 years. That's not uncommon. But what they typically do is they typically refresh it, mid-cycle action. They'll change the fascia, the headlights, they update stuff. Tesla's been making the Model 3 and it's essentially unchanged from what it looks like since late 2017, early 2018. We're pushing 2023. And if you buy a 2023 Model 3, what has changed? Things that add value to the functional objectives of the vehicle. And that's what I want to point out, is that rather than making a new fascia or new trim level, like a Tesla Model 3 plus, or I don't even know, LTR, right? They could just make something up that doesn't actually add that much functional value. What they're doing is they put the heat pump in the Model 3 starting in 2021. Do you remember that? They got rid of the super bottle and added the heat pump so that it performs better in cold weather climates. Any improvements that they've made to the electronics, we've seen those realized in the battery packs of the new Model Ys and most likely the new Model 3s. So for example, our first Model 3 that we tore down had 5 temperature sensor locations on each of the 4 modules inside the battery. That adds cost, 5 little sensors. But as they collected data in 2018 and 19, they probably realized they didn't need 5 temperature sensors for each of the 4 modules. They dropped it to 2. So they eliminated the number of temperature sensors inside the battery by 60%. They also reduced the amount of foam that's used on the underside of the cells. They got rid of the plastic shielding around that foam. They depopulated some of the circuitry on those circuit boards for the BMS. Now, these are things that are much more granular that only someone like Munro Associates would be able to find. The fact that a new Model 3 or Y has 2 temperature sensors on each of the modules instead of 5. Now, how does that benefit the customer? So by them saving costs there, they're able to invest it in the heat pump system, which is more. So the continual improvement in how that organization adds value to the customer it's a different model. And then we could get into how the vehicles are delivered and how they're ordered. I've ordered, I think, 4 Teslas in my life. I've ordered all of our Model 3s and Ys, the ones that we've torn down. And I've ordered the Model S Plaid. And man, is it easy. You log on, click, 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 put my name in, And you drive a Tesla, right?
Yeah, I do. Yeah.
So easy. And I purchased two vehicles personally that were not Teslas because I have three young children. I have a dog. I live on a dirt road. I get a lot of snow. Sometimes they don't plow. So I need a bigger, taller SUV. I could drive a Cybertruck. That would be
Yeah.
great. So what I'm getting at is, um, I wish Tesla made a large SUV. Just if they made a big SUV like an R1S or slightly larger, I'd be driving it right now, but I don't. But my point is, actually, I forgot the point I was making.
Oh,
Where were we going?
well, okay. Well, you were talking about how the ordering and all that, and the
Oh, yeah.
dealership is so
So
much better as well. Yeah.
ordering my vehicle. So I ordered my GM product in the fall of 2021, and early 2022. It took like an act of Congress for me to get it because of the chip
Yeah.
shortage.
Yeah.
It's who you know. I knew someone at GM. I had a phone call, and they moved my order up. Then when it came into the dealership pretended like they didn't have it, and then I saw it listed for sale on their website. So I tried to buy it off the website, my VIN number, which I ordered. And then I got a phone call from the dealer, and they're like, "Oh, hey, your vehicle's in." So only after I tried to buy it off their website,
Hmm.
they called me and said, "Oh, your vehicle's in." And it was a horrible experience. Because everybody was in the dark, and Tesla actually updates you when your vehicle's coming. I know the windows move around and people complain
Yeah.
about that, but my buying process was so much easier with Teslas, and cutting out all of that. I think Sandy and I talked about this. We get a magazine called Crane's Business. It's Detroit business, and we noticed a lot of the top businesses in the state are, like, for revenue and
Dealerships.
wealth, are
Hmm.
car dealerships.
Yeah.
Like, I'm not going to name them by name, but all of them,
Hmm.
it's like, oh, Suburban, LaFontaine, billions of
Hmm.
$1 billion,
Yeah.
$1 billion. Where does that money come from? That
Yeah.
gets sliced out of that transaction. So by eliminating the dealership network, where does that savings go? Some goes back to the organization, Tesla, but some gets sent back down to the consumer, because you'll end up getting more car. You get more car for less dollar.
Okay. Yeah. So you've jumped from the components of the car to the business model. I want to bring you back, which is awesome. This is my space. I love the business model, but your expertise, and I want to dig in further, is beyond the components of the car. What about the manufacturing and the way that Tesla does the manufacturing? And can you comment on, Elon's focus that the factories are the product? How do you guys interpret that? I've got my interpretation, others have as well, but I'd be curious to hear what you guys
Yeah.
think when you hear the factories are the product.
So we were not impressed at all when we first saw the Model 3,
Right.
particularly because the complexity of the body. And our first Model 3 actually had three different types of manufacturing methodologies on the outer door ring:
Mm.
sinusoidal laser welds, spot welds, and Henrobs. So to have three different types of manufacturing methodology on the door ring was asinine. And so the things that were easy, Tesla was struggling at. The things that were hard, Tesla was excelling at. So it's difficult to create that highly integrated EV architecture. The industry around the world, Honda, Ford, GM, Toyota, they have the manufacturing of the bodies and building of the vehicles at high volume. They have that mastered. There's a
Mm.
large group of people all over the world that have mastered building vehicles at volume in high quality. So we initially lampooned the Tesla because the build quality was poor. We got an early VIN number. Now, because when you're talking about manufacturing, they also were building in the NUMMI plant, which is less than ideal. When you're building in a plant that was set up to build the Toyota Matrix
Mhm.
and the Pontiac Vibe, I think that's what was built there. You're starting at a disadvantage. The paint shop is not built based on your vehicle. The body shop's not built or laid out based on your vehicle. The lines and the conveyors are set up to build an internal combustion engine vehicle. So if you move past the Fremont factory and go to Giga Texas, which I was in, did you go in Giga
I did.
Texas?
Yep.
Okay, yeah.
I was there.
So when you start from a clean slate and you can integrate your battery production and pack production into the plant, you eliminate a huge amount of costs, because in Giga Nevada, they had to build Giga Nevada for a place for them to do the subassembly buildup of, first of all, making the cells and building the packs. But then you have to ship those from Nevada to Fremont. A huge amount of cost and time associated with that. So there's a big advantage. Putting your pack assembly and cell production on site, where you're casting casting the Giga castings and doing body assembly. That means that you essentially are going mostly raw materials in, vehicle out. You're getting back to basics. That's what Henry Ford did. Raw materials in, vehicle out. And he got that from flying over a slaughterhouse. He saw cows going in, steaks coming out.
So let me ask that question, because I did just watch an incredible YouTube video by Connecting the Dots, and he's talking about the Project Highland for Tesla, and he was saying that that's an Easter egg because Highland is Highland Park that Ford had, and he did explain how Ford already had way back in 1930s this materials in and out. And in Highland they actually had both the river and the train coming in to deliver the raw materials right into the factory, and then out comes the cars, and they were able to do it at mass production.
Yep.
So this idea of everything housed in one area is not new, and Giga Texas is obviously trying to replicate that to the 10th degree. But why did the other OEMs, why did Ford themselves forget this?
So it's not. So I'm not a historian when it comes to traditional OEMs decision making, but there was a period of time, particularly in the late 90s and early 2000s, where we, Munro, supported several OEMs in their fight against reducing EHPV, so earned hours per vehicle. So that's how much labor you were paying people to assemble the vehicles in the assembly plants. Now, I don't want to get on the politics of union labor versus non-union labor.
Right.
But let's say you were building a vehicle that was highly integrated, and you had union workers, which are very expensive in Michigan, building seats, building instrument panels, building wire harnesses, very labor intensive for a low cost piece. The vehicle would cost so much more. So Sandy will say it's MBAs, but there's many executives that realize that they could ship the assembly of their seats to Mexico, the wire harnesses to Mexico or the Far East. Mm-hmm. And what happened was you had people making $1 an hour wiring harnesses. Then you pay to ship a shipping container across the ocean.
Right.
And now you have wire harnesses show up that cost you $10, where it would cost you $100 to have, union labor assemble them. It's just a fact of the economics of it. And more of the vehicle was being outsourced. So first it started with seats, instrument panels, then it moved to front-end modules. So it changed how the vehicles were designed. Early vehicles were body on frame with like a whole closed front end. But then they realized is if you take that front end of the vehicle off and create it as a module, a front-end module, now it's a big, large steel or magnesium module. Then you can put the radiator and the condenser in it and the fans and the fascia and the bumper. Now that can be built out. Then the body shop used to stamp all the parts in the plant and put it together. Well, now they realized that large portions of the vehicle, they could have those subassembly welded together in some lower cost area and shipped in. So now they're not even stamping the whole body. So what happens is on paper, you start to look like a hero because you've cut costs incredibly. But the one thing that OEMs failed to realize is when you rely on your suppliers now to do these parts, how do they make money? They make money when the vehicle is more complicated and less efficient.
Yeah.
The more complicated it is, the less efficient it is, the more their part costs. So the tier one and tier two suppliers were not necessarily motivated to serve the customer. Now, this is the thing that I point out all the time to many of our clients, our OEM clients, that when you go to a tier one and say, I want thermal system components for my EV, how have they been trained? They've been trained by the old school methodologies of supplying commercial off the shelf components at bare minimum prices made in weird, far reaching places of the earth. You buy all these off the shelf components, you put them under the hood, and now you have to do your engineering work and create all the lines to make them all together. And what you get is a fragmented, inefficient design with low cost commercial off the shelf components, but a higher cost, higher weight, less efficient, poor performing vehicle. So I think we come full circle. There's still a lot of DNA in OEMs that rely heavily on tier ones and tier twos to do much of the heavy lifting. And there's a lot of amazing tier ones out there. Some tier ones are now realizing that they need to step up their game and create more elegant solutions when it comes to integration and performance combined, so that they can offer systems to keep OEMs from insourcing, like Tesla did. So now you have this tier one community, many of which we work with and support, that are very carefully looking at where they fit in the future of EVs and how can they be competitive in terms of their technology and how it compares to the best of the best.
Yeah, so Tesla is, Elon has been quoted many times over and over. Factories are their product, and they're making the factories to be as, what do you call it, a dreadnought, robotic as possible. And so you were talking about the cost of human labor, but if he uses, more robots, then it could be more processed efficiency.
Yeah,
Yeah.
humans are okay. So humans are highly adaptable. They're expensive when they break down or get injured, but humans are okay if the design is so elegant that you don't need very many. And back to this is where that complexity example that I gave. So if you think of the trim level complexity scenario that I gave, you're in Dallas, you work at the SUV plant for GM. When you're standing there on the side of the line, you may have to build a police version of a Tahoe, RST. Now you have a GMC. I mean, it's a wild amount of complexity. With complexity comes added variation. With added variation comes lower quality. So now you have the opportunity for that human to make an error in how they're installing one fascia versus the other. If the clip strategy changes, you introduce error for using the wrong tooling, line side. Maybe there's a fixture for one and not the other, and that variation adds size to your plant. If you need more line side kitting, meaning you have to have all these different items at the line, it means the line has to be bigger. So with Tesla, sticking to a low amount of colors, first of all, and a low amount of trims or no trims, when you're selecting a long range versus a non-long range, the battery that shows up on line side looks the same. So from a manufacturing perspective, it's the same. And the big thing is wire harnesses. So some vehicles you buy, they have almost no features. Like in the past, you could get one that doesn't have power windows. You don't have a nice screen. You have a cheap radio. You have 6 speakers, not 11. So what an OEM would do, they would make a special wire harness just for that low trim level. And then the mid trim level, they'd have a harness. Then the mid upper, they have a harness. Then the highest, they'd have a harness. And then the special premium. So they may have 6 wire harnesses. So now when you're installing a wire harness, you have to pick the right one. They have different pigtails. And the most common error for quality oftentimes is missed connections or pinched wires or all sorts of problems. We haven't verified this yet, but at the plant, you will have one wire harness for all Model 3s and one wire harness for all Model Ys, because they're giving away FSD beta hardware on all vehicles. So if
Yeah.
Tesla wanted to save $1 billion a year, I've said this interview, if you didn't order FSD beta, they wouldn't ship the hardware. And then if you wanted it, you could pay 15 grand and they'd send a service technician out to you and install it. But that's in the car no matter what, because they're also using it to process and collect data that they're sending back, whether or not you're driving with it or not. And it's also used, but it's way overpowered for the basic safety features that all Teslas come with. So they could install a lower cost module that would handle lane keep assist, forward crash collision, the basic safety features that are that take much less processing capability than the FSD beta hardware. So I find it amazing that Tesla is willing to give away that hardware, but what that does is they're getting it back tenfold on reduction of complexity in the manufacturing plant. Mm-hmm. And then if they make a running change, so let's say they decide to cut 30 cents out of their wire harness. So people are installing wire harnesses every day. And now you got a new one coming that, let's say, it reduces the amount of tape on a takeout and the candy striping changes. They can now, at that plant, one point in time, explain the difference, if it changes at all, the manufacturing process, and very quickly train that worker that, okay, now this section is going to be a little difficult or maybe easier to install. And then from that point on, you can track that improvement in cost or weight or whatever. And that's why I think Tesla's able to make more iterative changes, because once they make an iterative change, it doesn't cascade into 7 different trim levels. It cascades into everything.
Gotcha. Yeah. Joe Justice talked about how Tesla can do innovation changes right in the line itself. Mm-hmm. Within every day, they make changes, not needing a committee, not needing budget, not needing a month to make these decisions or even longer. And that's because, again, complexity. But how much longer can they keep this where they, I would imagine that other OEMs who were just, started, they did the same thing, Model T, right? The whole Ford concept, all except for black, which is what they're, Tesla's doing now with the Cybertruck. Cory, what do you say to the, people quite often, what they'll say, the common narrative, right, is that Teslas are just iPads on a car. And, at some point, won't these cars eventually just kind of expand beyond just their, 1 or 2 trims and go have more? But I think my understanding is that what Tesla's doing is that they're really consolidating everything into software, and they're now just kind of giving updates through the air, and that's how they differentiate their products. So what's your comment when you hear people say it's just an iPad? All these other OEMs, they have 100 years of experience of how to create cars. They just slap an iPad and it's good to go.
So this isn't my deep area of expertise, but we did recently talk to an expert. His name is Thomas Mueller. He works for a company called Wipro. And man, he talked for 45 minutes to Sandy and I about the advantage that Tesla has and what other OEMs are trying to emulate. And essentially, they create a software-first vehicle, like you just mentioned, that has that updatability and a hardware that doesn't lock in the features. So the way traditional OEMs have created vehicles is if you have a liftgate that has a programmable height. So if you've ever had an SUV, you can program it to stop at certain heights. It can sense if somebody's there. All those features and functions were programmed into a box, a controller, onto that hardware, not changeable whatsoever, and sold by the supplier that sells that liftgate and that system. And they were highly motivated by making money selling that module and that feature and that service. But once you put that feature and that service in the car, then that has to talk to the rest of the modules and the rest of the operating system of the vehicle. But you were not able to go in and rewrite the functionality of that supplier's features and functions. Tesla's approach is different. They essentially have nothing that's locked, from meaning its capabilities are locked into the hardware. They're through software able to refine the function of the vehicle, and they've even addressed several of their warranty issues. I think you used to be able to play music on the speaker outside. Well, that was deemed to be a violation of some sort of NISTA law, so they addressed it through an update. So they even had features and functions that they didn't realize were problems, and they fixed it. They had a braking issue. I remember there was some sort of braking issue back in 2018 or 19. They changed the programming of the vehicle, and they were able to fix that. Traditional OEMs, many people say, oh, they have a 100-year advantage. That is where they were disadvantaged. I used to drive a 2009 Yukon. And when you got in, I bought it in 2013, and I drove it for 7 years. And when you got in that thing last year, and you looked at the screen, you would have thought you were playing Atari in 1980. I mean, the resolution was like 360p. The backup camera, all I could tell is if there was maybe something there. And imagine if that was a Tesla sold in 2009, I would have had the opportunity to continually upgrade that. So there's certain core elements that need to stay ahead of the game. That is screen quality and screen interface ability. So like the ability to touch the screen, the haptic feel, whether you have OLED or mini LED, your screen and what you see and touch needs to be far ahead of the capabilities so you can last for about 6 to 10 years. Mm-hmm. That's important. The second thing is hardware upgradability. So I think Tesla recently announced that you won't be able to put hardware 4 in a vehicle that had hardware 2.5 or 2. At a certain point, the backwards compatibility isn't going to be possible because your sensor suites, the wiring, how the vehicle is set up, won't be able to jive with the processing power and capability of the new hardware. At a certain point, that's not planned obsolescence, that's just natural obsolescence. So if somebody bought a 2013 Model S, there's no way they should expect the computing power of a 2026 Model S to be able to be backwards compatible. It's just, that's unreasonable. So it's the reasonableness of upgradability, and then maybe an expectation of saying, if you buy this vehicle, we'll guarantee you can upgrade it for 6 years. After that, we'll upgrade it up to 6 years and then beyond. I think it'd be nice if OEMs let you know the hardware upgradable runway, and then the software upgrades should be in perpetuity. But I hope they don't do what Apple did with almost forced obsolescence. After 2 years, they did the battery throttling. You remember that? Where if you had an iPhone 6 and the iPhone 7 came out, you upgraded the new iOS, and all of a sudden your battery life was horrible. It's like, man, I want an iPhone 8 now or 7, and that was they did that by design to kind of push you to upgrade faster. They shouldn't do that, and I don't think they're doing that.
Okay. Going back to manufacturing and factories, in the recent Q4 earnings call, Zach Kirkhorn said, hey, let's not focus so much on auto GM, but what we really focus is operating margin. What's your understanding of what he meant by that?
He said, this was on the earnings call, operating margin?
Yep. Operating margin is the key thing for them.
Well, I always like to simplify things. So as president of Munro Associates, my main responsibility is to make sure that this business operates in a profitable manner. So you have to factor in more than just our engineering services. So I'm going to apply this to me. So we have engineering services. We have the MunroLive channel. We have defense services. We have reports that we sell. How they make up our revenue split varies over time. Their profitability varies greatly. When we sell a report, it's typically much higher margin if the report has sold already to make up its initial cost than it is selling an engineering services job. MunroLive is actually pretty profitable as well because we have a team of 3. We produce 520 discrete pieces of video content a year. That was last year.
Wow.
And much of it's monetized. We have brand deals, and we do pretty well just if you carved out MunroLive as a business. So I have to balance how our business operates and how we invest our money. So I believe, so I didn't actually hear the comment. I didn't hear the quote. I'm hearing it only through you.
Yeah.
A business is more than just one of its entities. So I think they have Tesla Solar. They have the robot. What I forget. What's the robot called?
Tesla bot, Optimus.
They have Optimus, Tesla Solar. They have the battery backups. There's the mega packs, the charging infrastructure. But one thing I think that's oftentimes misvalued is the value of the data collected through the millions and millions of miles driven on FSD, whether that's FSD beta or just collected. Many OEMs are essentially a half a decade or a decade behind in their understanding of what it takes for a vehicle to drive on a road with a set of cameras, ultrasonic sensors, radar sensors, no LiDAR for Tesla, and I think the value of that data may become even more valuable when autonomous driving becomes more prevalent. And I think the road for that, the path for that is much longer than many people think, because I heard some other day, somebody said there's 1 billion vehicles on the road today, like 1 billion. And I'm like, wait a second, that doesn't make any sense. But actually it does make sense, because I don't know how many are sold a year, 50 million globally.
75 million, I thought, yeah.
Yeah, so okay. 75 million. And when a vehicle's sold, it stays on the road for years and years and years. And then other countries, vehicles are on the road for much longer. But 1 billion vehicles. So it will take decades upon decades for all of those vehicles to be off the road once we hit 100% EVs. And we're so far from 100% EVs. So for the next 20 or 30 years, there will still be, right now, majority stake internal combustion engine vehicles. Then eventually it'll be 50-50. And then it'll be a minority stake for another probably 20 or 30 years, because you have some fractions of the earth that'll hold out forever. So to shift the entire globe to an autonomous driving fleet is like a half of a century worth of effort to eradicate the world of people driving their vehicle down the road, spewing diesel or gas fumes. And I know I'm going kind of off topic here, but I think that operating margin is really important, because if Tesla has strengths that'll prop up the business that are unrelated to their automotive business, they should continue to leverage that, whether that's Tesla Semi, Solar, any of their other.
Okay. What's your comments and opinion and research on raw materials and the batteries specifically? What is the advantage that Tesla has in regard to batteries? We heard that GM switched back from their Ultium back to from the pouches cylinders. Yeah.
Yeah. So
you were one of the first that showed a 4680, didn't you?
Yes. I believe we were the first people to chisel out an actual 4680 from a production vehicle. So first of all, I'll touch on GM. So GM is heavily committed to pouch style cells with LG. So I believe the announcement of GM going to 4680 form factor gives GM an advantage in negotiating their pricing power with LG. So when GM announced the Ultium platform, they said, we're going to have 50 kilowatt hour packs, 100, 150 kilowatt hour packs, 200 kilowatt hour packs. The real advantage is massive, 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 massive scale. The only way for it to be super successful is to make 1 million cars a year or more where all the pouches are the same. Because if you vary the width or height of the pouch, and now you have more complexity, the cost is gonna go up. You need that scale. Raw materials are not that worrisome to me unless you have a high cobalt or nickel concentration in your battery. Many OEMs are trying to reduce cobalt. GM announced that they were limiting the amount of cobalt in their chemistry, the Ultium platform. GM has a mix of lithium, or Tesla has a mix of LFP batteries for their Chinese models. We've even seen some of those batteries here by CATL. Much less energy dense, a little safer actually. But what I'm getting at is, I think GM announcing going to 4680, what's really important is to understand what's the mix. Will it be 5%? Will it be 30%? Will it be 50%? Will it be all of their future vehicles beyond 2025? Will they eventually phase out the Ultium? Will Ultium remain a minority player? There's so many unknowns. And I think it's a negotiating tactic that GM is going to use. They probably had enough time to study the 4680 Tesla Model Y, in my guess. And because of that, they may see that it's a manufacturing advantage and a cost advantage over the pouch style cells. Pouch style cells are more expensive when you factor in all of the ancillary mounting provisions needed to secure those pouches together compared to a structural pack with a bunch of foam.
Okay. Thank you for that. And so obviously Tesla has made moves for securing lithium. So are the others. It's a race to try to get as much as they can. Tesla's going into refineries. So let's switch back to operating margin and auto margin. And my big question is, do you think that Tesla might actually even do another reduction in prices and just totally, do checkmate against the others OEMs? And what's your thought on the Gen 3 platform? And is Project Highland the next version of Model 3? Is that a real thing? Has that really been announced?
So I want to talk about the US market and the Gen 3 platform. Yeah. So I do calls on a weekly basis, sometimes a biweekly basis, with a couple of financial institutions. And one of the most common questions I get is, why isn't Tesla attacking the highest volume market in the United States? If there was a Tesla SUV, 2-row and 3-row, right now that was being made at mass volume, even at not as good of a range, because when you make an SUV, it's more of a brick, you're going to need a bigger battery, just like a Cybertruck, they would be killing it. So if I were a traditional OEM, and like GM or VW, where I have a Q4 and ID4, if I have a Blazer and Equinox coming out soon, you better hope that Gen 3 platform doesn't have two beautifully designed gigacasting 4680 efficient powertrain Teslas falling right behind. Because I think the only thing holding Tesla back is the fact that they're not in the two most prevalent markets, the three. So large truck, large SUV, medium, small SUV, game over. That would be game over.
What happened to the compact car? The elusive 35,000 under?
I think the compact car would be a bad move. So the reason why it'd be a bad move, hear me out here. Inflation has done a lot of damage on the psyche of the American consumer. Now, we are still stuck. Like, I was born in the 80s. You were probably born in the 80s or
older than you.
Maybe, yeah. I don't know. I whatever. So I grew up where my first vehicle I paid $3,500 for, and it was a 10-year-old Nissan Maxima that cost $17,500 new. I love that car. It was amazing. I still would drive it today if I could find one in good shape. I actually, at one point, I owned 3 or 4 of them. I love the 4-door sports car. It had 185 horsepower, manual transmission, no airbags, no anti-lock brakes, 4-wheel disc. I love that car. It weighed 2,900 pounds. Nissan Maxima forever. Yeah. But my point is, that vehicle cost $17,500 in 1991. Factor inflation, what would that vehicle sell for now?
Mm-hmm.
I think it's like $37,000. But look at what it actually costs to make that 4-door steel sedan with no airbags, no anti-lock brakes, no ultra high strength steel. It would not pass SORB. It would not get 5-star crash test rating. It would not pass roof crush. It wouldn't pass any of the safety standards. None of them. So it was a subpar product that would, based on inflation, sell for in the $30,000. Now, for some reason, the modern consumer today thinks, I want a $25,000 electric vehicle. Do you realize how crazy that is? It's like the most asinine thing in the world. Like, am I going to hire someone to watch my children if the going rate for daycare in my area is $1,700 a month? I'm going to go in and say, I know it's $1,700 a month. I want the same care, but I want to pay $600 a month. It's just unreasonable. So,
but Elon has said the Gen 3 platform is going to be half the cost, half the factory space, half the price.
So that will be an altruistic goal if Tesla offers the world a $25,000 EV. It's going to have to be small. It'll only have one motor. It'll have a small battery. It'll have to be relatively light. If it has hardware 4.0, that's like a free gift, because just because it's an EV doesn't mean it has to come with all that sensor suite, but it probably will, because Tesla will sell every vehicle with the hardware capabilities to be autonomous. They won't sell it without. That makes it even more amazing, because if you look at some of the cheaper OEMs out there, EVs, they don't, like the Bolt. Can you put it in autopilot? No.
Mm-hmm.
Sure, it might be 27 grand or 30 grand, but it's just an electric hatch little car. So GM's almost there with their $30,000 EV. But people have to want to buy it. It has to have the functional objectives to perform at a level that satisfies the consumer. So will it be a tiny 2-door hatch like a Honda CR-V back in the day? Or was it not CR-V? Honda, was it HRV? I don't know my Honda cars. The little tiny Honda, the Civic hatch.
The Civic, yeah. Okay, so what about Project Highland? What have you heard about that? Is that a real project? Did we just make that up?
I've only heard of Project Highland since you mentioned it here today.
What?
Yeah.
The whole Twitter community, we've all been talking about this. We don't even know where it came from.
I cannot tell you how busy I am. So Sandy and I'm actually supposed to be booking my flights right here. Yeah. I'm supposed to be booking my flights to be out of the country for 10 days. And I'm headed to Chicago next week. I'm sorry, we're busy. We had clients in all week, meeting after meeting.
Gotcha.
I can only spend
what we understood is Project Highland is supposed to be the revised new Model 3, and it's going to be cheaper to make, cheaper version of it, but much more, improved version of it. So the question is it going to be, lower priced? Because the Model 3 is already getting under the $40,000 mark. Yeah. And so I've always saying that, why don't they just create a variant of the Model 3, cut out some of the stuff you were talking about, and then offer it for $5,000 cheaper, especially with Project Highland comes, which they've learned a lot of manufacturing efficiencies to apply that. And we've not even seen yet the efficiencies of Giga Texas and Giga Berlin, the efficiency of the 4680s, and the software margins that possibly can kind of justify them to cutting the price even further if they're confident that they can make it up with insurance or with FSD purchases.
Yeah. So if I had to imagine a Model 3 that was lower cost, it would have a Giga casting in the front, a Giga casting in the rear. It would use a structural battery pack with 4680s. It would eliminate the floor pan, essentially be like the Texas Model Y. You could realize significant savings there, particularly in the manufacturing costs. So, but I don't know if they're going to make larger step changes. At a certain point, if you look at a vehicle, there's some things you have to have. And if you want to understand the things you have to have, look at someone who takes their vehicle to a racetrack and look at what they remove that's not necessary.
Right.
You ever seen that?
Yes,
All the interior
that's a good-
trim out, the trunk trim, the rear seats, there's so much junk in a car.
Yeah.
It's truly not necessary, but it aids in the satisfaction when you drive the car. It's quiet. You probably want all that noise abatement patches in the dash and in the doors. You don't want to drive down the road where it sounds like you're in a school bus, right? So the American consumer or the global consumer has a high standard when it comes to their enjoyment of their vehicle, whether it's NVH, noise, vibration, and harshness. There's an incredible amount of money that is spent on laminated glass. So look at the early Model 3s. They did not have laminated glass in the front windows, in the front, the front door windows. The Model Y has it. It's expensive. 2 layers with a laminate in between. It's because EVs don't have the engine in the engine bay, which actually drowns out a lot of harsh noise. Without that, you hear everything. So now you have laminated glass everywhere. So this brings me back to my point that I've been making multiple times. Is it truly about making the cheapest possible vehicle, or is it having the functional objectives that satisfy the customer? Because if it was a race to the bottom, which we oftentimes see in the automotive industry, meaning a race to the lowest cost, it's a race to the bottom to achieve these functional objectives. If you omit the requirements and objectives, the bottom goes even lower. And that's what I want to see. There's a couple other companies out there that are developing EVs. I can't say which ones they are, that take away the standards. They essentially say, we're going to make this thing as bare bones as possible. And if you want it to be quieter, you pay extra for door panels and stuff to make the price of entry lower for an electric vehicle. Because the cost of the batteries are so expensive, it makes the business case of making automobiles much more difficult. And that's really what it is. The motors and thermal systems are not that expensive. It's that battery. So big, so heavy, so expensive.
Okay. Let me learn more about Munro and Associates. You guys are very, very interesting. Your knowledge is just through the roof. I don't know if there's anybody else like you and Sandy and the other associates. So tell me about how this company was founded. What's the story? How did you meet Sandy? How many employees do you have?
That's a long story. I'll give you the bridge version.
Yeah.
So Sandy founded the company in 1988. He worked at Ford Motor Company for a decade before that. He was prompted to start the company after meeting Dr. Edward Deming, who was the father of Lean in Japan, and then came over and was helping Ford Motor Company. So Sandy started his company in 1988. I believe we incorporated in 1989. It was very small for the first decade. I believe we had maybe 10 employees by the end of the 90s. And when I hired in 2005, we had 25 employees. My employee number is 47. So from 1988 to 2005, there was only 47 employees ever hired at Munro, and 25 of them still work there because, I was 47, there was 25 there. People had either retired, died, or quit, So, and in 2005, we were small, but we were very diversified. So Sandy's first decade, he supported Boeing, McDonnell Douglas, a toy company, NASA, GM, Ford, Chrysler, all the OEMs. We supported agriculture companies, tractor companies. And it was primarily through old school consulting, workshop style, where we would go on site and do workshops, kind of like hired gun type of things. And we were rather expensive. So we're a boutique consulting firm that taught lean design. Then in the late 90s, early 2000s, the company started to hire several salaried engineers instead of just these consultants.
No
And
NDAs.
I was hired as an intern. So I
Yeah.
went to Kettering University in Flint, Michigan, and I'm from Nebraska, and everybody at Kettering is required to get an internship. It's called co-op program, where you work for 3 months, you go to school for 3 months, work for 3 months, school for 3 months, the whole year for 5 years. Kettering, Munro came up to the job fair to hire an intern because they had already hired a B section intern and I was A section. So the guy's name was Ryan, and they needed to hire someone else because when he went to school, they wanted me to be there. So
Gotcha.
So they sent up Ryan, the other intern, to be at the job fair, and there was about 100 people applied. They had a huge stack of resumes, but I remember when I talked to Ryan, I go, "Hey, I'm Cory. I took AP Spanish in high school. It was so bad." And he's like, "Don't tell me about that." He's like, "Tell me about yourself." So I talked about RC cars, and I played football. I had knee surgery, and he had knee surgery, and he liked RC cars. So we hit it off. So anyways, I got invited for an interview, and they invited 2 people out of 100 for an interview. And what they liked about me is that my dad was a mechanic, and on my resume, I had Chuck's Truck Service, privately commissioned auto mechanic, and I totally inflated what I did in high school.
Yeah, sure.
And because they did teardowns, they liked the fact they weren't going to have to train me how to use tools. So I get hired. The other guy never showed up for the interview. I was the only one who showed up. So in 2005, I started as an intern. And enough about me. Let's go back to Munro. So I've been at Munro for 17 years, but during that course, we grow from 25 to about 100. So we're at just under 100 people, and we had a small facility. Now we have a bigger facility, and we've transitioned to primarily a salaried work staff that does amazing work when it comes to cost engineering. So costing is something that became really prevalent about a decade ago, and it's what we've honed our craft in, particularly when we started helping the EPA with the CAFE standard development in 2006, 7, 8, 9, and 10. We did a project in conjunction with FEV. I can talk about it because it was presented to Congress. So it's like publicly available. You could go find it somewhere. That kind of put us on the map from our skills as a costing engineering firm. And we supported several large OEMs in Detroit doing much of their cost engineering. And that represents probably 30 or 40% of our business. But then we realized the EV industry, the shift to EVs was coming. And we invested heavily in tearing down a BMW i3, a Chevy Bolt, a Jaguar I-Pace, a Nissan Leaf, a Model 3, a Model Y, a Model S. So we started tearing down dozens of EVs before the demand was there. Most of the OEMs in Detroit, like Trump was elected president, and they were just pumping oil like crazy, and no one cared about green. Barack Obama wasn't president anymore. So we stuck to it, and it ended up turning really into a huge advantage for us in 2018 when we got our Model 3. And then we got our Model Y in 2020, and that aligned with the pandemic, which was horrible timing because we were getting ready to have a lot of people come in and look at the Model Y. And that's when I proposed the idea in a kind of an emergency meeting at Munro. I had just been promoted to president. And I said, I pitched this whole thing. I bought the domain, MunroLive.com, personally.
Gotta go online.
Yeah. I created the YouTube channel. We already had a YouTube channel. I don't know if you knew that. It's still there.
I mean,
it's called
massive
Munro,
at this point, though.
It's called Munro
_live. Munro _live, right?
No.
Oh.
No. That must be a spoof. That's got to be a spoof account. It's called Munro Associates. Most people never know this. It's still there.
Still there. Okay.
It was the account that was created by our PR firm, and it's where they occasionally put videos. I actually asked for the login information for that, and I was told no, you don't know how to create videos for YouTube. So MunroLive was actually created personally. I personally created it to
Nice.
show it as an example in the meeting. And then the pandemic hit, and it was like, oh my God, we got to do something. That I just did it. And then only after like a year, I transitioned everything over to the company.
Yeah.
But I personally paid for everything
Got it
for
going.
the first year or two. And it was like a proof of concept that it would work. And then the first year, I filmed the first like 100 videos with a couple other engineers here. And then I hired Eric and another guy named Zach, who's no longer at Munro. But then 2021, we really added a lot more content. 2022, now we have 3 people, and here we are.
Yeah.
So
here you are. Yeah, pretty big, and I think people love the kind of like just it is highly produced, but it's not highly produced. It looks like you guys are just talking and you're ripping things out and all that. But how do you afford these cars? How do you decide to buy all these cars you just said? And then do you just expect that you're going to get paid back through consulting or some sort of job with the OEMs? And
it's a 2-pronged approach. So we get about 10 press vehicles a year. So we're considered a media entity. And
so they give it to you.
We don't pay to rent the Hyundai Ioniq or the Q4. Eric does a great job. He reaches out and asks all these people, and eventually they say yes. The only one that always says no is Lucid and GM. They always say no. But everybody else, we get press vehicles from Chrysler, Hyundai, BMW. We get them and we test them and we film on them. But the vehicles for the teardowns, those we clearly have to buy. We try and be judicious about what's like super popular, and there's a engineering aspect to it. So buying the vehicle is relatively cheap, $100,000. It sounds like a lot, but it's not. Tearing it down, cataloging it, photographing it, and then doing the cost analysis on it to create a report is expensive.
That's
sometimes 4 to 7 times as expensive just to do the analysis. You're talking $1 million for a complicated vehicle. What that means is we have to be careful about which vehicles we choose to do the full teardown. Then when we do the videos, that's just like gravy. We do the videos, we might make 50 to 100 grand off of the videos if they do well. Like on a Tesla, we tore down our 4680 Tesla from Texas. I think I wanted to do 20 videos on it. I think we did 20 videos. We made like $1,500 to $2,000 a video just on ad revenue.
Yeah.
And then we sold a couple $100,000 worth of 4680 cells, which was like on top of everything. And because of that, we were able to really justify, we wrote an engineering report that we also sell. So if you're out there listening to this, that's our most popular report. Everybody buys it because it compares the 4680 to the 2170 Model Y. Very interesting. And so our business model is twofold. We need to always make sure that our teardowns are chosen judiciously because we could lose money, and we have in the past. When we bought the BMW i3 in 2015, we did a full analysis on it. We've never made our money back on that.
When are you going to do Tesla Semi? And are you asking folks like us to actually support this?
So we are. So we did a Tesla Semi sticker campaign. So we have this little sticker that has Sandy. He looks like Uncle Sam. It says, Uncle Sandy wants you to help us buy the Tesla Semi. Because the cost of the Semi is so astronomical, we're going to do everything in our power to try and source one. I think we're about 15 or 17% there for the fundraising. We have a long way to go, but it's also going to be a long time before we can get one. We would love to do a Tesla Semi teardown and put it on YouTube for all the viewers. So if you're watching this, I'm sure you can find your way to MunroLive.com, and it's $15 for a sticker and $50 if you want Sandy to sign it. Sounds like a lot. A lot of people buy it, right? Yeah. And actually, I think I have one right here.
The sticker?
Yeah. Right here.
Nice. Yeah, that's awesome. You are a master marketer, I tell you. You, like you said, that MunroLive is just massive. And then you've got a Sandy who's like this character that is just so loved by everybody. He goes on his rants, I guess, but he's like, I love the one that you guys. I wouldn't want to mention you. I love the one where you guys said, I don't know who you were upset with, but basically it's like, we are the experts in cost analysis.
Yeah.
Why would anybody, here's the books. I mean, yeah, how did anybody even want to question that you guys know every single cost of every single part?
Yeah. It's what we do. And we have seen more cars completely tore down than most people have driven.
Yeah.
And that's what people don't understand. Like, most people have driven maybe 20 vehicles in their life, if you count rental cars, friends' cars. I can tell you for a fact, I have seen well over 100 vehicles completely tore down. Every
part,
airbox, every wire harness. And I've been in thousands of meetings talking about all of the attributes of all of these pieces. It's what we do.
Yeah.
And I just like now that we have a platform to talk to great people like you, so that your listeners can hopefully get a little value from our conversation.
Oh, for sure. We learned so much today, the whole list. I mean, you're the only person that can actually explain it in actual detail, not just high level. Yes, they're more efficient manufacturing. Yes, they have cheaper parts. Yes, they're brilliant in this business model, but you guys actually physically know. When are you going to do the Cybertruck? That should be a little bit straightforward,
as soon as possible.
Right?
As soon as possible. So
who has the reservation for one?
So we have like 5 different people with them on order, all with the understanding that whoever gets theirs first will tear down. But most likely what's going to happen is we'll probably buy one on the secondary market at a premium. So whoever gets theirs first in the country, or in the first week, will immediately be able to sell it for double. And we most likely will pay that. So if you're out there watching and you get yours within
Cybertruck, sell it. Yeah.
a week, sell it.
Yeah.
And we'll buy it and we'll tear it down. And that's how we got our Model Y from Texas.
Somebody sold it to you.
We had a viewer.
His
name is Alex from Florida, who got it. And he's like, hey, I'm getting a Texas Model Y. You guys want it? We didn't even have one on order, because if you order one, there was no guarantee you were going to get one from Texas. And he sold it to us at cost, no markup. Great guy. Because of that, we hooked him up with some stuff. I think we're going to give him some more stuff as a thank you. But
this Cybertruck, though, will break the internet because it is not a car. It's not. It's going to be so brand new. We're all going to want to see all the innovations. Elon has said it's going to be the best product he's ever made. It's going to have the most technology in it. Be curious. Everybody would be so curious what's inside there.
And the sad part is we're going to fast track the teardown. So when we get that thing, no road trip, nothing, because anybody can do a road trip. Anybody can drive it. Anybody can put stuff in the bed. But we want to be the first people on the internet to get the skin off, to get the battery out. Yeah.
Oh my God, that's going to be awesome. Okay. Well, thank you so much, Cory. I really appreciate your time. I know you said you're very busy. You guys are traveling soon. And everyone, please follow Cory on Twitter. His handle is at Cory Steuben, Steuben. Sandy is at Teardown Titan. Thank you, Cory, for finally getting him on Twitter. But he's already taken off. He's just a great guy. And of course, you got to check out their YouTube at MunroLive. And they are just rocking it with incredible videos. And like we said earlier, the number of viewers that they get is just crazy. Good job with that. And so Munro and Associates website is at leandesign.com. That is you just heard the story of why that is named that way decades ago. So thank you so much, Cory. This is awesome. I'm going to have to write down all the lists of all the ways that Tesla has an advantage over their competitors. If you think there's some other advantages, please send a comment. But really appreciate this time with you, Cory.
All right. Thanks, Herbert.
Awesome.